Okay, so in this next example, we're looking at finding the vertex of a quadratic. Okay, so to find the vertex h comma k of a quadratic, we use the equation h equals negative b over 2a, and then the k is just going to be f of that answer. Okay, so then that's going to give us the coordinates of our vertex of the parabola. We be sure, let's see, know this. Okay, so you want to commit this to memory. You should know this. It's not a. I mean, it's very. It'll be very helpful if you know how to find the vertex of a parabola. I wouldn't say it's a major formula, but it's very useful, and it's not too bad to learn. So the x coordinate of the vertex of a parabola is going to be h, which is equal to negative b over 2a. So let's look at this example 3. It says sketch the graph of this quadratic. Okay, so I think we can do the same thing we did last time, but last time it was given to us in standard form. Now we should be able to, or we are able to, convert this to standard form. But I'm just going to use that vertex formula that we have above. So above, I'm going to start with the vertex. So then my vertex, the x coordinate of my vertex is going to be h equals negative b over 2a. Right. So then let's start there with our graph. So let's solve for h. So in this case, it's going to be, now what's our b? Now keep in mind, this is the general form of a quadratic. It's in the form ax squared plus bx plus c. Our a, so let's just kind of evaluate this really quickly. So if we have this quadratic in example 3, what's our a? Okay, so think about what your answer is, and then tell me if it's positive or negative. So then tell me, so does that mean that the parabola opens upward or downward? Okay, so to answer those questions, the a should be -1. It's the leading coefficient, which is -1. So since it's negative, that means that our parabola should open downward. When we actually look further into it, a negative leading coefficient means that the right-hand side should be going down. But in this context, the parabola should be opening down. Okay. So if we want the coordinates of the vertex, we would say negative b. So our b in this case is 6. So it's going to be -6 over 2a. 2 times -1. So then that's 6 divided by 2, which is 3. So the x coordinate of our vertex should be 3. Let's go ahead and find the y coordinate, which is our k. So then we want to do f of 3. So then we plug in 3 for f. That's going to be a -9. 6 times 3 is 18. So then that's 9 minus 8. It should be 1. So then the coordinates of our vertex are 3, 1. Okay. So now we have our vertex. So we also know the axis of symmetry. Now we can just find points that are equidistant from the axis on either side. So let's generate a graph. Okay. Let's see here. So we got the vertex. So we have our axis of symmetry. 3. Okay. So let's do, and we said the parabola opens downward over 3 and up 1. So I'll do a graph like this. Just try to get a sense of the correct viewing window. So this will be a positive x, positive y. Let's see. The vertex is over. So let me see. We got 1, 2, 3, 4, 5. -1. 1 is up here. And then 1, 2, 3. So then if we go 1, 2, 3, if we plot this vertex 1, 2, 3, and up 1, we should be here. Okay. So then, just like before, that means that this is our axis of symmetry. So that means any point on this parabola other than the vertex should be equidistant from another point on the opposite side of this axis. So again, we call this our axis of symmetry. So then, so let's just find points on the left and right and kind of get a decent graph. We plotted the vertex. We have a sense of our axis of symmetry. So now, right now, on the axis of symmetry, our x value, yeah, that was a good event. Oh, I don't think I invited you all. I meant to invite you all to see Despicable Me today, or actually on Thursday. Um, so this upcoming Thursday, which is like Monday, Tuesday, Wednesday, so a couple of days from today's lecture, um, South DeKalb Mall at 6 o'clock, there will be a free screening of The Amazing Spider-Man. So it's a free screening, but your admission is actually you have to buy something from the concession stand, and your receipt serves as your ticket. So um, only thing is when I went last Thursday, it was like really hot. So hopefully they'll have that fixed. But otherwise, it'll be a lot of fun, and it's fairly inexpensive. But anyway, all right. So for generating this parabola, so right now our x value is 3. So then if we go, for instance, 1 to the right, we'll be at 4. So when x is 4, what's our y? So if we plug 4 in, that's going to be 16. That's going to be a negative 16. And then 24. So that's 8. 8 minus 8 is 0. So then 1, 2, 3, 4. So when x is 4, our y should be 0. So then if we go to the left, if we have 1 to the right, then that means we're automatically given 1 to the left, which is here. Okay, let's find a few more. So instead of going further to the right, I'm going to choose something to the left. Now when x is 1, what's my y value? So if we plug in 1, the first term is going to be negative 1. Then 6 times 1 is 6, so that's now 5. And then 5 minus 8 is negative 3. So over 1 and down 1, 2, 3. Then beyond that, we're going to go off. So now 2 to the left, we're at negative 3. So now if we go 2 to the right of our axis of symmetry, we should also be at negative 3. Okay. So then if we connect these with a smooth curve, something like that, and like that. Anyway, okay, so we get a graph that looks like this, and I'm just going to do a quick confirmation. So I want to check it here in my calculator. So I'm just going to go to y equals and graph this. We have a negative, so we have a negative x squared. Oh, I have the same. Okay. Negative x squared plus 6x minus 8. Okay, then I want to just choose a similar window to what I have. So I can go negative 1 for my x's, and the max will be 1, 2, 3, 4, 5. So I'll go 5 is the max. The scale is 1. The y minimum, 1, 2, 3. I go down to 4 and up to 2. And the scale is 1. And we should get a similar graph. It crosses at 2. 1, 2, 3, 4. 2 and 4. So yeah, we have a similar graph. The vertex looks correct and everything.